actually going to take a little bit of a sideways step and not be as technical as the last presenter. I'm actually replacing somebody else from our company, Sensear, who he couldn't make it. As you can tell by my accent, I'm not a local. I've flown in from Australia for the show, so they've actually asked me just to step in and do a bit of a presentation on noise interference and audio quality. The sideways step I'm going to take is mainly because of the industry we're in and what we do. So we are an active hearing protection communication device manufacturer. So where the previous presenter was talking about the codecs and the interference from external and internal measures, we try to combat that with an active hearing protection device that has a level of communication. So if you've wanted the show, you may have seen the Sensear product on either the Kenwood stand or our own. But yeah, I just want to delve into this one a little bit and talk more about the effect of external pressures on audio quality and primarily from noise. So basically, where we sit, we know from a two-way radio perspective, it doesn't matter what they are. Most of the time, they're used in a high noise environment. And as we saw on that demonstration before, once you do hit that high noise environment, there are a lot of factors that get transmitted through the radio itself, and sometimes the codecs can't handle it, sometimes the software can't handle it, and it needs a little bit of a hand. I'm not going to run through all of this, and I think we all know it, but obviously as the level of noise increases, you've got to do a lot more from a communication perspective. So even without radio, for instance, you have to yell in a loud noise environment. Once you go to a radio, it creates even more issues as well. So what we look at in this presentation is from a transmit side of things, from a receive side of things, and then how that affects even hearing protection from that side of things as well, and the compromise that people make so that they can communicate properly. So, as I said before, and as we've seen, environmental noise, so basically reduces a lot of that SNR speech at the radio side of things. It reduces the performance, the intelligibility, and as I said before, a lot of the digital codecs and vocoders have a very, very hard time dealing with that noise. It pretty much just transmits everything, and you get your poor intelligibility at the other end. So we've got products and we've tried to create new things that help combat that side of things. And as you say, going through new technologies, new vocoders, and doing all the testing is where it's going to be in a few years' time. But the issue is now, not down the line. So even from a receive side of things, this image actually shows how people normally wear, say, a two-way radio, how they use it. So you've got a remote speaker mic. If they're in a loud environment, they're usually putting in a passive earplug or a passive ear muff, which is then causing additional issues because obviously they can't hear what's coming out of that. So let alone the fact that the information that's going into the radio may have background noise. You've then got the other end where that noise and that interference that's also transmitting is also being blocked by a passive hearing device. So it's all pretty much adding up. So as I just said, in a lot of these environments, that radio wearer has to wear some sort of hearing protection. It's in the US, it's a OSHA requirement. Other parts of the world, they have their own occupational health and safety requirements. So there are some issues in there. And in some environments, the radio itself actually contributes to the exposure of those high noises. Background noise is loud, so you turn your radio up louder. I don't know if anyone here is from law enforcement, but if after a few years of wearing your speaker mic on your shoulder, you tend to find you're deaf in that ear and not in the other, and that's because you're turning up your radio louder and louder, and every time the speaker goes off, you're gradually getting more and more deaf. So there are a lot of noise impacts around not only the transmit side, but the receive side of things. So from our perspective, we've basically combined the hearing protection side of things with the communications. So we look at headsets essentially, and we look at NRR ratings to make sure they're obviously accredited and they're protecting your hearing. But we don't want to overexpose the wearer to a lot of those limits. So sometimes people don't like to use certain hearing protection units, so you've got to look at the compromise they make. Sometimes they remove them altogether because they don't like wearing an earmuff, they like an earplug, or vice versa. And one of the things we actually do within our product as well is we actually do have a level of speech processing. So a passive and an active product are completely different. As we see before, passive, you put in your earplug and you hear nothing. Something that we looked at and we looked at improving is essentially allowing the wearer to hear what's going on around them, but then controlling that level of noise to the ear. So it's great to be able to plug in your radio into a comms headset, but if that comms headset doesn't have a level of filtering within itself, you can still overexpose the wearer, and they can still gradually go deaf over time. So you've got to look at being able to improve and being able to limit, but keep safe what they hear in their ear. So you've got to really combine quite a few things when we're looking at this side of things. So from a transmit side of this project, we looked at doing some remedies. So with an ear muff product, you look at a close talk boom microphone. Usually that has noise cancellation properties that will cancel out all of those background noises. So when they do push to talk button, a lot of that background noise is not transmitted through the radio. Within that, we then look at, and as I said before, active hearing protection, where we do a lot of speech processing within that. So we take that signal coming through the radio, we digitise it, and we do a little massaging ourselves to ensure that once it hits the ear, it's more intelligible. From the noise cancelling boom mic perspective, it is pretty much just a transmit side remedy, and there's not a lot more that we can do from an ambient noise and from a speech perspective. We started looking at in-ear products, so picking up speech from inside the ear canal rather than an external environment being able to affect it, which seems to be going along extremely well, but we're still in some trial stages, and we've just released a product now that seems to be going well, but we've still got to do a little bit more with that side of things. From a receive, so noise cancellation is actually a pretty big thing at the moment. There are a lot of Bose headsets, there's a lot of headsets you can buy for airlines that do a lot of noise cancellation, which is extremely good. And if you don't know about noise cancellation, essentially it creates an anti-wave inside the headset to reduce a specific frequency from the external. But in some cases this isn't effective for some of those noise types that are out there. So there are some other products, some other technologies like noise suppression is another option. And something else is the speech processing and the spatial awareness. So some products out there now are looking at basically external microphones mounted onto that product that allows the wearer to hear everything that's going on around them. Gives them 360-degree situational awareness. And it also then controls the amount of noise going to the ear, which is obviously doing a lot from a protection perspective. But it also makes it a pretty safe technology as it's aware of surrounding. It usually looks at decibel levels that are out there, and then can limit that decibel level to the ear. So in that, when you're talking about a two-way radio signal, it can essentially block out all that background noise and just transmit the pure voice that's coming through from a two-way radio signal. Within that, to work with that radio signal, we do a lot of digital speech processing, and essentially it's estimating background noise. It uses some algorithms to suppress the background noise but enhance people's speech. So, and as it says, it works fairly well in a lot of environments, best for constant noise, but yeah, it's definitely a work in process. I mean, we've got some extremely good technology behind it, some really good algorithms that take out that background noise, but obviously everything can be improved on. And as it says here, there's the noise reduction side of things. We can do anywhere from 10 to 20 decibels in noise reduction. So when you're doing a test or when someone's talking over their radio, and that they can limit the amount of external noise to the ear, it means the communication is a lot better. And that's pretty much it for me. As I said, it's not overly technical. It's not really my field from a technical perspective, but yeah, if you'd like to know anything more, feel free to visit the Sensear website, get in touch with us, or come and see us down the show with what we've got there.
Great.